What is up, brothers and sisters? I am your host, your brother, your professor, Mr. O'Neil Barnaby, founder and director of the Black Math Academy. Again, showing you guys what intelligent black society is all about. All right, continuing on my series of tips, tricks, and alternative methods to help solve math problems a little easier. Today, I'm going to be discussing the rules of divisibility. So, if there are no further questions, and I don't seem to see any, let's get into it. So the rules of divisibility are a way to look at a number and tell whether or not it's divisible by a certain digit. As opposed to you take a number and you divide it by a digit and you see if it works. If it doesn't, you pick another number, divide by it and see if it works. You can avoid that process and use these rules and literally just look at it, and you'll be able to tell whether or not it's divisible by a specific digit. So for example, let's say you had the number 2,340. And from that number, you want to find out whether or not it's divisible by the values between 1 and 10. But let's say we're going to include 1 and 10 as well. So the numbers between 1 and 10, but we're going to include 1 and 10 within that list. So let's begin. So the rule for 1, which I wrote down here, says that everything is divisible by 1. So no matter what number you pick, whether it's a whole number or a fraction, doesn't matter, it's divisible by 1. So far, between the numbers from 1 and 10, the number 2,340 is divisible by 1. So we'll write 1 so far. The rule for 2 says that it has to be even. Even means that it ends in either 0, 2, 4, 6, or 8. Since 2,340 ends in 0, it's even, therefore it's divisible by 2. So we'll add 2 to the list. The rule for 3 says that the sum of its digits is divisible by 3. So we're going to add the digits within the number 2,340 and see if that number is divisible by 3. So 2 plus 3 is 5. 5 plus 4 is 9. 9 plus 0 is still 9. 9 is divisible by 3 because 9 divided by 3 is 3. So therefore, 2,340 is divisible by 3. And just to make clear, when we say divisible by or divisibility, meaning that when you divide by a number, you don't get a decimal or a fraction as an answer. You get a whole number. I just want to make sure I make that clear to everybody. All right, the rule for 4 says that the last 2 digits is divisible by 4. So we're only going to look at the last 2 digits within the number, and we're going to see if that part is divisible by 4. So within the number 2,340, we have the last 2, which is the number 40. And 40 is divisible by 4 because 40 divided by 4 is 10. Therefore, the entire number, 2,340, is divisible by 4. So 4 is added to the list. The rule for 5 says that it has to end in either 0 or 5. Our number ends in 0, so therefore that number is divisible by 5. We'll add 5 to the list. The rule for 6 says that it has to be divisible by both 2 and 3. So the rule for 6 is a combination of 2 rules, the rule for 2 and the rule for 3. 2 says it has to be even. 3 says the sum of its digits, it has to be divisible by 3. Well, if we look at our list, we already have 2 and 3 within it, so it's already divisible by both of those digits. Therefore, 2,340 is divisible by 6. The rule for 7 says you take the last digit, double it, and then subtract it from the remaining. I know this particular rule is probably the oddest one out of the bunch, but this rule does work, and let me demonstrate how that works. So we're going to take the last digit, which is the 0. The 0. We're going to double it, so 0 times 2, which is still 0, and then we're going to subtract it from the remaining. The remaining is the 2, 3, 4, because the 0 is what we took, and the remaining part is this 234. So 234 minus 0 is still 234. Now, it's a little difficult to tell whether or not it's divisible by 7 because of how big it is. But luckily, the rule that for 7, you can apply it once again. So what we can do is take the next number, the 4, and start the process all over again. So we take 4, we're going to double it. 4 times 2 is 8. And we're going to subtract that from the remaining, which would be the 23 in this case. So 23 minus 8. 23 minus 8 is 15. And 15 is not divisible by 7, because 15 divided by 7 is a fraction. Won't be able to get a whole number. So therefore, 2,340 is not divisible by 7. So we won't add 7 to our list so far. The rule for 8 says that the last 3 digits is divisible by 8. Now, if you've been paying attention, it looks very closely related to the rule for 4. 4 said we had to look at the last 2 digits, but the rule for 8 says we have to look at the last 3. So we look at the number 340, and we're going to see if that's divisible by 8. So the number is kind of big, but you can use some of your rules of multiples and factors to see if it's divisible by 8. We know that 320 is divisible by 8 because 32, 4 times 8 is 32, and then times 10 becomes 320. But if you add 20 to 320, it becomes this 340. So that 20 that we added to it, because it's not a multiple of 8, therefore 340 can't be a multiple of 8. What we know about multiples is that if you keep adding a number over and over again to itself, those answers are also multiples of the original number. So since we added 20, 20 is not a multiple of 8. So therefore, it couldn't have been a multiple of 8 to begin with. So 8 is not a value that can go into 2,340. Therefore, we won't add it to our list. The rule for 9 says that the sum of its digits is divisible by 9. So again, we've been paying attention. It looks very similar to the rule for 3. 3 says if you look at the sum of its digits is divisible by 3. 9 says the sum of its digits has to be divisible by 9 this time. So just makes sense. Since we already added these digits together, 2, 3, and 4, and 0, that was a 9. 9 is divisible by 9. So therefore, 2,340 is divisible by 9. So we'll add 9 to our list. And the rule for 10 says it has to end in 0. And that's probably the most basic and the easiest one. Our number does end in 0 again, so therefore our number is divisible by 10. So 10 is a part of the list. So between the numbers from 1 to 10, including 1 and 10, we have 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 total digits between the numbers 1 and 10, including 1 and 10, that are able to go into 2,340 and give you a whole number as an answer when you divide it. So that is another example of what Intelligent Black Society is all about. Don't forget to like, share, comment, and subscribe to all of our social media pages, our Facebook page, Instagram page, and YouTube page. And always remember that what gets us into trouble is not what we don't know. It's what we know for sure that just ain't so. Be blessed, y'all.